Hello friends, my name is THENUA. Today I will discuss about the matrix operations in Simulink, or I can say I am going to extend the concept which I have introduced in my last lecture. So you have to build a Simulink model that perform these operations, right? So in my last lecture I have told you how you can enter a matrix in a Simulink model. So simply you have to perform the transpose operation. I have also discussed that. You have to perform the inverse operation, and you have to perform some multiplication, or we can say you have to use some gain blocks, right? So this is simply gain, and you have to perform some square operation, square root operation, right? And the data is complex data. Okay, we have the real as well as imaginary data. So let's see how we can implement this in the Simulink. So before designing the Simulink model, you can look on the problem. So simply we have the two, I can say we have the two section of the problem. This is the one section and this is the another section. Okay, so when I want to design a Simulink model, I can implement this section separately and this section separately, and after that I can add these two sections, right? That will result in the final output. Okay, so let's see how we can do this in the Simulink. So I have opened one model in the Simulink. So first of all I have to choose one constant block, or not one block, even I have to use two blocks, right? Because I have to enter the two matrix. So I can make the copy by just pressing Ctrl and drag this block, right? After that I have to perform one transpose operation and other is inverse operation, right? So for the inverse operation we can have one block that is available in the maths operation, very interesting, or we can say very useful block, that is the math function, right? So we can use this, and here we can use the MATLAB interpreted function also, right? What I have used in the in my previous lecture. So I'm taking that block also. So that is inside the user defined function. So that is interpreted function, right? So this is interpreted function. Okay, so what are the matrices? First I enter those matrices. First matrix is 3 2.5i. So this is 3 2.5 I. We can directly write I. Okay, MATLAB understand this. Then minus 2i 3.2. Okay, so after entering this matrix we have to perform the transpose operation, and after that we have to multiply with the gain. Okay, so this is the first part. So you can resize this just to check the data, what data we have written inside it. Okay, now you have to perform the transpose operation. So by double clicking on this block you can check what are the options available. So you can check here, we can perform the log 10 is to power something, log 10, magnitude to the power 2, right? Square, power, conjugate, reciprocal, a lot of options are here, right? So we are required to perform the transpose. So I can choose the transpose. Okay, apply. So after this we will get the transpose, and in the transpose we have to multiply it with the 1/5, right? So if you want to multiply with something, in that case you have to use the gain block, right? So gain block is available in commonly used blocks, so we can use the gain block, and you have to change the value of gain, that is 1/5. Okay, and you have to add the two sections. So for that you can use the adder block, right? So this will be the adder. So we have complete the one part, right? This is the matrix. It will make the transpose of that matrix. After that we are multiplying that with the 1/5. Okay, in the other section we have to enter the matrix. So we can enter the matrix. So here you can check we have the square root of each element in this matrix, right? So there's one way you can write sqrt of this, sqrt of this, all these things, or because square root is applicable on all the elements, so we can just write the simply all these elements, and we can perform the square root operation over the whole matrix, and after that we can perform the inverse operation, and finally we can multiply again. Okay, so we are adopting this approach. So first of all, I enter this matrix without a square root. Okay, so this is minus 3i, 2.2, 2.5, then 5.4, right? After this, I have to perform the square root, then inverse. Okay, you can resize this. Now you have to perform the inverse. So for the inverse, I can use the simple inv function, right? And if you want the data in the 2D format, you can just remove this. Okay, after this I have to perform, before this I have to use one block because this is performing the inverse, but before inverse I have to take the square root of this. So for square root we can use one block that is available in this, that is sqrt. Okay, so we can insert this block in between. Now the element of this matrix will be square root. After that we are taking the inverse. Okay, and finally we are multiplying with the gain. So the value of gain block is sqrt 3.3i, right? So we can increase the size to visualize, and now you can connect this. Okay, and we can connect one display from the sink just to check the output. Okay, we can fit the model in the window so it can be visible properly. Now you can run this. So we are getting the output. Now we have to resize this display block, right? So this is the output. And instead of this interpreted MATLAB function, we have one more option by which you can perform the inverse operation, right? So I would like to introduce that block also. So that is available in the math operation, and that is product of elements. Okay, so I'm just removing this block and putting this block. Okay, but I have to configure this block. I have to use this division sign, and I have to choose this matrix operation, right? After that, apply. Okay, so now you can check it converted into the inverse. Okay, so now it is performing the inverse operation, right? And now you can run the model. You can check there is no change in the result, or there is no error. That means this block is also working in the same manner as the interpreted MATLAB function was working. Okay, so there are so many blocks in the Simulink, so you can solve a problem in multiple ways. Okay, you can verify the output with the MATLAB results also. So I have the MATLAB results. These are the MATLAB results. So simply in one line I have performed this operation, right? These are the results, so that are similar to your Simulink model, right? So that means we have implemented the problem correctly. So I hope you understood the matrix operations, how you can perform the operations over the matrices by using different blocks in the Simulink. So hopefully you have enjoyed this lecture. If you have enjoyed this lecture, please like this lecture and share with your friends. And don't forget to subscribe my channel to get the notification of other videos. Thank you.